Welcome everyone. Today we are looking at a fascinating framework called SkillX, which focuses on automating skill knowledge bases for LLM agents. Our goal is to show you how we are moving away from isolated learning paradigms and stepping into a world of plug-and-play, hierarchical experience. To understand why we need SkillX, let's first look at the structural flaws in how agents currently learn from experience. First, we have isolated learning, where agents repeatedly execute the same tasks, causing massive redundant exploration. Second, there's weak generalization. Monolithic experiences extracted from isolated tasks transfer poorly to novel environments, especially when high-quality training data is scarce. Finally, we face a capability bottleneck. When an agent harvests experience purely through its own self-reflection, its potential is fundamentally capped by the base model's current capability frontier. To solve these flaws, SkillX proposes a paradigm shift from monolithic context to itemized modularity. The status quo, such as Claude skills, relies on long context that is progressively revealed. This requires a complex system environment and multi-round interactions, which often leads to brittle reasoning. SkillX, instead, stores multi-level skills as distinct items. This means a lightweight system environment, highly transferable skills, and the convenience of one-time prompt loading. Let's look at the overall SkillX architecture. It starts with a strong backbone agent, like GLM 4.6, feeding into the SkillX pipeline. This pipeline handles multi-level skills design, iterative skills refinement, and exploratory skills expansion. The output is a plug-and-play SkillKB, or skill knowledge base, which can then be directly plugged into a weaker base agent to instantly boost its performance. The magic of this architecture lies in structuring experience hierarchically. SkillX breaks skills down into 3 tiers. At the top, we have planning skills, which specify the task organization and how functional skills should be composed to solve a complete task. In the middle, functional skills act as macro operations, providing reusable, tool-based subroutines that accomplish specific subqueries. At the bottom, atomic skills provide execution specifications aligned with a single tool. This 3-tiered design yields skills that are concise, composable, and robust to distributional shifts. Let's dissect the anatomy of these skills using an example task. Name the artist most recommended to me on Spotify. The planning skill outlines the high-level steps: authenticate with Spotify, fetch personalized recommendations, and return the artist name. The functional skill acts as a macro operation, such as listing all APIs in an app. Meanwhile, the atomic skill handles the precise execution specification, like Spotify authentication using stored credentials. How do we actually build these structured blocks? We distill them from raw trajectories. First, the agent performs rollouts on training tasks. Second, we explicitly filter out non-essential transitions like exploration, backtracking, and trial and error. Third, we compress the successful trajectory into an ordered set of planning skills. Finally, we use that plan to iteratively prompt the extraction of the functional and atomic skills. But SkillX doesn't stop at extraction, it features continuous autonomous refinement. The system actively merges similar skills by clustering them and merging candidate update directions. It also filters out poor skills or decomposes overly complex ones lacking new logic. This cycle maximizes test distribution success rates exclusively via execution feedback, meaning zero new human data is required. To escape the limitations of the initial seed data, SkillX employs exploratory skills expansion. Through experience-guided exploration, the system proactively targets underutilized tools and failure-prone behaviors. It then safely generates and validates synthesis tasks to test these novel skills before committing them to the knowledge base. Putting it all together, we get the unified SkillX engine. Training tasks go through rollout and skills extraction, producing trajectories and pseudo-plans. These feed into the skills refinement loop of filtering and merging. This is followed by experience-guiding exploration and synthesis tasks, ultimately populating a comprehensive multi-level skills library. What is the ultimate result? Massive competence transfer across models. By taking a skill knowledge base generated by a highly capable model like GLM 4.6 and plugging it into a weaker model like the Qwen 3-32B base agent, we see incredible gains. The structured, hierarchical experience instantly elevates the execution efficiency and yields a plus 10% task success rate across complex benchmarks. In conclusion, SkillX is about democratizing agent capability. Representation matters. Hierarchical abstraction ensures absolute reusability over brittle, monolithic prompt stuffing. Automation scales. Through extraction, refinement, and expansion, complex knowledge bases evolve entirely without human supervision. And finally, capability transfer allows us to break the capability bottleneck, using strong frontier models to automatically upgrade smaller, efficient models. For more details, code and implementation are available at github.com/zjunlp/skillx. Thank you for watching.